Okay, let's look at problem 15.6. Here's the diagram. A winch, there's the winch, delivers a horizontal towing force F to its cable at A. Alright? So this towing force is there at A, and of course we know that our assumption is that the same tension in the cable runs throughout the cable. Okay, so there's the same tension throughout. And this force varies as shown in this graph. There's a force time graph, and for the first 12 seconds there is a constant force of 360 Newton. Then from 12 to 24 seconds it increases linearly from 360 to 600. It's a force time curve. Okay, determine the speed of the 80 kilogram bucket at time equals 24 seconds. Okay, so again, like I always try to do, we've got force, we want some velocity information, and we have time information. So we can use the principle of impulse and momentum. Okay, so let's just start. Where do we start? We start from the beginning. We draw a free body diagram of this, because what are we looking at? We're trying to find the speed of the bucket. So that is our mass. So we know that if that's the bucket, we will have 2 times T, or they call it F, let's call it F acting up, and we're going to have weight acting down. Right? There's our free body diagram. Right? We just draw a free body diagram of this guy, and we've got the force acting up, and we've got the weight acting down. There we go. Okay, and there is the mass. So we've got mv1 plus the sum of all the impulses, okay, is equal to mv2. Alright, so now we can take say up as positive. So the initial velocity was 0, so we have no initial momentum. Now we need to consider what's happening over here. The weight down is straightforward because that is a constant force. So we can say minus mg, right, times 24 seconds. But now, what is happening here? So at point A, we see that the force times time curve looks like this over the 24 seconds. So whatever's happening here, we need to multiply it by 2. Okay. So let's just do that, because we've got 2 of those. Now, what is happening? So recall in the earlier lectures, we saw that, remember that the impulse is the integral of f dt. And what does this mean? It is simply the area under the curve of the force time curve. It's the area under the curve. So what we need to do is, we need to find this total area. So from 0 to 12, we have a force of 360, right? The force times the time, 12. So there's the impulse from 0 to 12. Then we also need to consider calculate what is the impulse from 12 to 24. Okay? You may have some nice little equation for dealing with the trapezoid. I'm not so smart, so I'm just going to break this up into a square and a rectangle, and a triangle. So we're going to have, remember, we're still 2 of those, right? We're still inside the bracket. So we're going to have 360 times 24 minus 12. That's this over there. That's that square, rectangle actually. And then we need to also consider the triangle, which is half. And the base also is 24 minus 12. And the height will be 600 minus 360. Okay? So you need to consider the total area, and then this equals mv2. Alright? Let me just insert some more space here. Okay guys, I don't have the entire solution in front of me. Let's see if I can find it. Okay, so this we then have, I'm going to write out here, we have 0, and we're going to have minus this over here will be just again 80 times 9.81 times 24 seconds. Okay, that's your mg times 24 seconds, plus this entire thing should equal 20,160 Newton seconds. Okay, impulse, and this should equal 80 because that's the mass of the bucket times V2, and we calculate V2 to be 16.6 meters per second. Okay, so we learned that your force time curve, the area under this curve gives you your impulse, and so we applied that to our calculation over here. Okay guys, go well.